All right, welcome back everybody to Full Stack Web Development for Beginners. So last time we left off, we finished our book search route and add a new book route. And so now we can kind of do something like this. We can type in a search term, hit enter, and we get back a list of search results. We finished that, and now let's kind of talk about SQL injection and why we are a little bit vulnerable to it as we currently have written our app. So if we had a malicious user come to our page here, they could kind of just work out a little bit how our SQL query works just by typing in a search term, right? So like we typed in revolution, and we can see clearly that we're getting back results that have that word somewhere in this string of text in the title or subtype, right? So they can probably realize that we're probably using the like clause, and that's pretty easy to figure out just by looking at things. And they can also see that we're probably pulling back 1, 2, 3, 4, 5 columns, right? So that's two pretty easy things to figure out just by using our app. The other thing is, I'm going to go back to the code really quick here. Let's just do a Control-C to stop our server. And up here in our search books route, I'm going to get rid of this .trim for now, and we're going to put that back in once we talk about how to protect ourselves from SQL injection. And then let's pull up Workbench here so we can see all of our tables. And currently we don't really store any sensitive user data or anything like that, but let's pretend that we might be doing that. So I'm going to go ahead and add a new table in here just for pretend's sake. So let me zoom in a bit. So I'm going to create a table user data, which is going to hold usernames, passwords, and user type, just pretending that we are storing sensitive data. So let's go ahead and run that query, and that'll create us a new table. If I refresh, we can see we now have a user data table. And now I'm just going to copy and paste an insert statement to put in some fake user data. So usernames, passwords, and user types. So let's go ahead and highlight that. Let's run that. Now if I right click my user data table and select rows, we can see that our table now has some sensitive information. Once again, our app is not using that, but this is just for pretend to kind of see how SQL injection might work. So I'll close this. Let's go ahead and open up a new query window here, right? And so our user was able to kind of figure out that we're doing something like this, right? Select some number of columns. Their guess was 5 columns, right? So 1, 2, 3, 4, 5. We don't know what they're selecting, but we know the amount of columns could be 5 from some table. We don't know or care where they're pulling it from. And then we know that they're using a where something is like, and then they have parentheses, and then our search term is stuck in here, right? So we used the word revolution, so that's probably getting stuck in there. And then there may or may not be an or where some other column is also like our search term, right? There might be another one where they're checking on another column, right? So this could go on and on. We don't really know how many times they're doing this. Well, we know because we wrote the app, but this is, we're pretending to be some, hacker who's trying to figure out how to inject SQL into our search form. So this may or may not kind of be happening. I'll just put etc. to say that there could be more code, right? Let's see what we could do. So currently we're doing something like this, right? Const s equals, and then we just pull in their search term from the query string, right? It was something like rec.query.bookSearch. So if our users enter the word revolution, we just kind of blindly concatenate that word in between these percent signs, right? And that's how we're pulling back our book data by search term. So what if a user were to put in a search term and then a single quote? So let's copy this. Oops. If this was put into our query string, right, it would replace all this, and we can see that our percent sign here turned to black. And that means that we actually pulled this out of the string, right? So our single quote here actually closed this first single quote, and that closed our string like prematurely here, right? So that's not good. What if we expanded on this, put a space and put a comment, which is just hyphen hyphen and then a space? What if we had a user put this into our search form? So let's copy all this. Let's see what might happen. and we'll replace all this with our new search term, paste it in there, and now we can see that we not only closed our string with our single quote, but we also just commented out the rest of the query that may or may not be running, right? That's really bad. So we commented out all this, and let's see why that could be bad. And first off, I just want to say that there's a great YouTube video that kind of explains this a lot better than I'm probably going to explain it. I think it was by Computer File, so I'll have a link to their video in the description. Very well worth watching that video, but I will do my best explaining kind of how this works. So, all right, back to it. So why is this bad here, right? We can actually put something in between our single quote and our comment and run our own SQL query in there, right? So if we went over here and modified our search term to do something like, I don't know, select, union, and then select, and our guess was that they're pulling back 5 columns, right? So we might try 5 columns first. So 1, 2, 3, 4, 5 from dual. So in MySQL, dual is just a placeholder table and kind of just query whatever you want from that placeholder. So we could put whatever we want here. I could put like, 9, 8, doesn't matter, but we're just gonna do 1, 2, 3, 4, 5 to keep it easy. And what we're kind of hypothesizing here is that if they are indeed selecting 5 columns, then we should be able to union our 1, 2, 3, 4, 5, which would just stick that at the bottom of the returned results, and it should appear on the front end of our website. So let's see what this might do. I'm gonna go ahead and copy all of this. So copy that. Let's go back and see. So we're not running our server, so let's come down here and do an npm start. Start up the server, come back over here to the page. Let's do a refresh, and let's paste in what we just put there, right? So revolution, and then union, select 1, 2, 3, 5 from dual. So let's see what happens here. Run that, and we don't get anything back. So what this tells me is that either we selected the incorrect number of columns, right? Because when we do a union, the columns must match, right? So either we got this wrong, or they're already protecting against SQL injection. Since we know that we're not protecting against SQL injection, we know that we got the number of columns incorrect. So what if they were doing 6 columns? Let's just try that. We're just gonna do this trial and error until we figure it out. So we'll do select 1, 2, 3, 4, 5, 6 from dual. Let's copy all of this, go back to the page, and let's try our new attempt here, selecting 6 columns. Again, we don't get anything back, so we're just going to continue with our trial and error. What if they were doing 7 columns, right? Let's add comma 7 from dual. Let's copy this again, go back to the page here, and paste that in, run it, and there we go. So now this is really bad because we've now confirmed that our union select is being queried, and we're pulling back those results and even displaying them on the front end of this page. So this is definitely open for SQL injection. So with this knowledge, right, let's see what we could do here. And just to kind of show you guys how this works, if I change this to say like Fyodor, I think is the first name of Dostoevsky. So if we do that term and do a search, we'll see that we're still pulling back some book results here, right? Because the last part of the string of the author's name is Fyodor, and if we look at what we modified our statement to, right, if we put this into here once more, right, so it would replace all of this, we can see that we only have 1% sign to the left of our search term rather than having it on both sides. So we've modified it to say pull back all books that have this word at the very end of this string, and that's why revolution wasn't working. It wasn't pulling anything back, right? On that, and see what else we can do. So I'll leave that up there. What if we changed it to, I'll just not write const s. What if we changed it to, and I'll just use Fyodor. So Fyodor, close quote, space, union, select. And we also know, if we go back here, we can see that the number 1 is not being printed out. So we're not going to use that for anything that we want to see on the screen, right? So if we go back to Workbench, let's do select 1, because we know that's not going to be on the screen. And what we want to do is pull these things out on the screen so we can see them, right? So let's do one table underscore name, table underscore schema, 4, 5, 6, 7, because the amount of columns that we're pulling back still have to be a total of 7 columns. 1, 2, 3, 4, 5, 6, 7 from information schema dot tables. And this is something that we can do in MySQL. This comes as part of schemas in MySQL. So don't forget our comment at the end. Let's go ahead and copy all this. So, we need to copy the whole thing, sorry. Copy the whole thing. Go back to the page here. Let's paste that in and see what happens. Run a search. Okay, we're getting back a whole bunch of stuff. We can see our schema is here and our table names are over here. So we're not interested in the information schema. We're interested in something that kind of relates to this web application, which is kind of like a library of sorts. So let's look for a schema that might match that. And here we go. So we have found a library schema. How appropriate, right? And over to our left, we have all of our tables that exist in this library database, right? We have book language, blah, blah, blah. And then down here, we have our sensitive user data table. So now our hacker is aware that we have some sensitive information in here, and now they're probably going to try to target what's inside of this table. So let's go ahead and see what they might do. So down here, I'll leave that up as well. Let's continue on. So Theodore, and then single quote, union, select, and we'll still do 1. And this time we're going to do column underscore name, and then we'll do 3, 4, 5, 6, 7. So we still need to have the same number of columns from information schema dot columns, where table name equals user data. And don't forget the comment at the end. So what we're doing is we're going to see if we can pull out all of the columns inside of this user data table. So let's copy all this, come back to the page here, and scroll back up, and let's go ahead and put that in as our search term, run a search, and we still get back our books, and look at that, ID, password, user type, and username. So now we know that this table does contain passwords and usernames and some other sensitive information. So that's not good. Let's go back and see if we can pull some of that data out, right? So I'll leave that up there as well. Let's do Theodore union select, and then 1, and then we'll do it was username, password, user type, and then what is that, 1, 2, 3, 4. So then we need to do 5, 6, 7 from user data. Let's see if we can pull out what's inside of that table. Copy all of this, go back to the page, let's try it out, paste it in, run a search, and there's our book data, and there we go. So we have now cracked the user data table, and we can pull back usernames and passwords. Although these passwords would most likely be hashed, at least I would hope so. Pretty common practice to not store passwords in clear text inside of a database. They're probably hashed, but it's still not good to be able to pull this kind of stuff out of a table from a search form like so. So let's talk about how we can protect against this, right? So what could we do here if our users entered something like this, right? So we know that, well, I'll put it back to that first thing we did, right? So get rid of that. Let's say we did, let's just use Theodore to be consistent. So this is what we first did, right? We did a single quote, and that was what closed our string, right? And then we had a comment. So we don't want to allow something like this to work, right? So if we put this in again, this is what it kind of looked like. So that would replace all of this. So what can we do to this single quote so it's not effective at closing our string, right? Well, we can escape it with a /, and you can see now that it does not close the string. The string is still closed where it is supposed to be closed after the final %. So now if we had our, union, select, blah, 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 right? That would all be part of this string in this like clause. So it would be harmless, right? Because it's all a string, it's not actually querying anything. So we need to escape our user input, and that's the whole thing that for protecting against SQL injection. So Hope that makes sense. And with that in mind, let's go back to the code here in search books. And the way we can escape user input is we have this pool object here, right? And this is what we're using to connect to MySQL. It is a pool of SQL connections, right? And that pool actually comes with a method. So you can do something like pool.escape and surround the entire user input to escape any characters that shouldn't be in that user input, right? Like single quotes. This will escape those and it will prevent stuff like what we just saw from happening. Also, since we kind of want it to be wrapped in single quotes and percent signs, let's go ahead and just do all that in the escape, right? So we can do a template literal, a percent sign, and then we'll have to concatenate this whole search term, and then we'll close it with the percent sign and close the template literal. And then we also need to put back in the dot trim, right? So we don't want any white space. So put that back in there. So now we just need to replace it down here properly. So currently we're kind of doing all this down here. I'll just highlight those first two characters, do a Control-D a few times, delete, and then on the right side as well, let's delete all that. Delete, and now we're just concatenating the S variable. And that already contains our single quote and percent sign. So save that. And then let's go see if our SQL injection still works. So come down here, let's do a Control-C to stop the server, npm start it back up. And then let's go ahead and come into Workbench, and let's copy this last one, which is what we use to get all of our user passwords. Copy that, come back to the browser, and let's see if we can get that to work. First, I will refresh on the /books route. So do a refresh in here, paste in our SQL injection, run a search, and now we can see we don't get back any data, and that's a good thing. That's basically how to protect against SQL injection. And then one more thing to explain here is that down in our so get or add book route is fine because we're not taking any user input in here, so this is fine. But insert book, we are taking in user input from the request body, right? So technically this could contain some malicious code, right, that we would have to protect ourselves from. However, since we are using the question mark placeholder here, the pool.query is going to automatically escape all of these inputs for us. So whenever you kind of use this placeholder to do your querying, it will do the escape work for you. You don't need to worry about anything else. So this is already good to go. The only thing I would add here is we forgot to do .trim last time, right? So we want to also trim any white space from the author and the title because those were free-form text boxes. Save that, and yeah, this should be already protected. So that's a quick little overview of SQL injection with some examples of how it works and why it's bad and how to protect against it. Basically, just want to make sure that you are escaping user input. And then in later videos, we'll kind of get to client-side attacks, which are cross-site scripting, right? We'll get to those because we also need to clean user input strings of those kinds of characters as well. But we haven't really finished our front end of this app yet, so I'm going to leave those explanations for later videos. That's about it for that, but it's a very important topic. Let's just quickly come down here and do a git add, git commit, and just say add SQL injection protection. Commit that, and we'll just do a git push origin master, get it pushed up to our repository, and that will seal up this video. So thanks for watching. I'll have a link to the next video in the description, and I hope to see you all there.